Introduction to the unit circle with trigonometric functions. What's the unit circle? It is basically a circle on an XY coordinate graph where each end of the circle goes as a radius of 1. In other words, when I'm looking at this circle here, it's centered on the origin. Here is location of 1, 0. I go 1 across for x, 0 for y. Up here, I go 0 for x1 for y. Over here, I go -1 on the x-axis, and it hasn't moved anywhere for y, so it's 0. And then down here, it's not moving anywhere on the x-axis, so it's 0 and then -1. This is the unit circle right here, and we're going to use the Pythagorean theorem to determine angles with this, as we learned in the last few days. If I drop a line here, make a radius from the origin all the way to the edge of the circle anywhere, well, that is the radius of 1, because I said my unit circle is 1. Given this now, what I do is I drop a line vertically down. And if you notice I drop it straight down here, I get a right triangle. I got a right angle there since it's dropping perpendicular down. And what I want you to notice here is here's 0, 0, the origin. And this is somewhere, but it's the length of 1. Here's a length of 1 right here in the vertical. Here's a length of 1 on the horizontal axis. So the distance here is somewhere the x-axis. On the x-axis, that horizontal, that line drops down for the x-axis somewhere is less than 1 for the x-coordinate. And then somewhere here, because here's 1 on the y-axis. It's somewhere the distance here from the origin to that point is also y is less than 1. It's some distance. And since we've created a right triangle here, I got an angle coming out of the origin, and that's what we're interested in, this angle here coming out of the origin across that line. And since it's a right triangle, that radius of 1 is the hypotenuse. Now, as I said, we have got a hypotenuse of 1 because I've taken a line from the origin all the way to one part of the circle. And I've dropped down a line here. I'm drawing it here right now. Apologize for that. Not being faster. Drop down a line here, and I've made a right triangle. And I know it's a triangle because I've got a leg here and a leg here, and here's my hypotenuse with a length of 1. So if we look at this angle here, coming from the origin, this angle theta, and that's what that little letter is, angle theta. Remember, cosine is adjacent over hypotenuse. So here's my adjacent line. It's the distance from the origin to the x-axis. That is my x-axis, and if that is adjacent over hypotenuse, that means the coordinate for the x-axis is the cosine. And then the opposite of this angle is this line right here, the y-axis. And remember, opposite of hypotenuse is the sine. So that means that the y-coordinate for this distance up here is distance starting from 0 up to here is going to be the sine, the opposite of our hypotenuse. So by having a cosine of theta and a sine of theta on the unit circle, we can determine the exact coordinate where that is, anywhere on the circle as that hypotenuse moves. So when I get these angles here with this right triangle I've driven, I've got the cosine of our hypotenuse, which is the coordinate for the x. And the inverse of that is simply the secant. And you can see how we get the secant right here. at the bottom. And then the sine is the opposite of this angle, theta. And here's my sine right here. And if you look at this, the cosecant is right here on the other side. It's just the inverse of the sine. And then the tangent, opposite over adjacent, y over x, is right here. And remember, I said this is always perpendicular to where the radius is. In this case, perpendicular to this hypotenuse. And then the cosecant is right here at the adjacent over opposite, right there. That's the inverse of it. The great thing about trigonometry at the unit circle is when we find our sine and cosine, we're actually finding the distance also. If I put in my calculator cosine of 50 degrees, and again, when I'm looking at this here, it's this 50 degrees right here, that angle. And the cosine, remember, is adjacent over hypotenuse. Well, my hypotenuse, remember, let's just look at this, cosine equals adjacent, put an A here, my writing's not that good with a little cursor here, over hypotenuse. Well, if my hypotenuse is 1, anything over 1 is itself, and I put in cosine of 50 degrees in my calculator, I get 0.64. And lo and behold, that is what this distance is. The distance from the origin to where this line drops, the x distance, is 0.64. Almost 2/3 of the way from the origin to the 1, 0 on the unit circle here, this point right here. And if I do the sine of 50 degrees, which is the opposite, this right here, opposite over the hypotenuse. And when I put in sine, that is going to be sine equals opposite over hypotenuse. And that's going to equal, and I put it in, I get 0.77 over the hypotenuse is 1, so it's 0.77. So my vertical distance is actually 0.77. So my cosine is my x, my sine is my y. Tangent, the opposite over adjacent. Now that I got to know what 0.77 for my sine and my cosine is 0.64, opposite over adjacent. 0.77 over 0.64 equals 1.203. And really all we're doing here with the secant, the cosecant, and the cotangent is finding the inverse of those. Or I'm sorry, excuse me, the reciprocal of those. Another quadrant. It's in the second quadrant here. So it's more 90 degrees, because here's 0 degrees, and here's 90 degrees right here. And halfway across is 180 degrees. So this is 120 degrees. It is about 2/3 of the way across the halfway mark. But I can still do something with this. I can still figure out my coordinates on that unit circle. Again, because this hypotenuse is still 1. As I said, I've still got a right triangle here. And I'm in the negative x area because it's less than 1, the x-axis, right here. Or less than 0, excuse me, right here. It's less than 1. I got to figure out what this distance is. Well, if I put in cosine of 120 degrees, again, cosine is adjacent, equal here, over hypotenuse. And that's going to be, I get a negative 0.5 over 1, because the hypotenuse is 1, so in a circle, is 0.5, negative 0.5. So it's literally halfway across here. My x-axis is negative. It's a distance of negative 0.5 from the origin. And then if I put sine of 120 degrees, and I get 0.87 when I put sine of 120 degrees. And it's going to be positive. 0.87 because it's still positive y-axis. So my coordinate is negative 5, which is the cosine of 120 degrees. And then 0.87, which is, about almost 90% of the way up on the y-axis. Still positive because it's on the positive y-axis. One more here. I've got an angle of 110 degrees rather than 120 degrees. And when I put in the cosine of 110 degrees, I get negative 0.342 because my x-axis, where it drops down here, is going to be in the negative x area, right here. And that distance is negative 0.342 because cosine equals adjacent over hypotenuse. And when I put in a cosine 110 degrees, I get negative 0.342 over hypotenuse, which is 1. Anything over itself is 1. So the distance here is the x-axis. The cosine is negative 0.342. Sine of 110 degrees is going to be 0.94. That's opposite of our hypotenuse, which is over 1. So it's 0.940, and that's the y distance. And also the sine of 110 degrees. And if I wanted to find the tangent, that's 0.940, which is the sine over the cosine, negative 0.342, to negative 2.75. And then how do I know tangent sine over cosine? Well, it's really just a simple replacement of fractions. If I know tangent equals opposite over adjacent, I could rewrite that as sine, which equals opposite over hypotenuse, all over the adjacent over hypotenuse. And what happens is these two cancel out, and I simply get opposite over adjacent.